A processor is the brain of a computer. It takes high-level instructions and information and breaks them down into ones and zeros. Even though processors are widely used in our homes, phones, computers, and other electronic devices, they're not widely understood. There are 5 main functional components of a processor: the input, the memory, arithmetic and logic unit, the control unit, and the output unit. These 5 components work together to process information and delegate tasks to the computer's other hardware. Today, we will learn how a processor works by explaining what the 5 components of a processor are and discussing how they interact. First, let's try to understand what the 5 components of a processor are. Of the 5, we will start with input. The input unit takes coded information from a user, such as a keyboard or a microphone, and immediately translates that data into binary and transmits it to the processor. This information is then either sent to be put into memory or used elsewhere in the processor. Next, we have the memory unit. Its function is to store programs and data. There are 2 types of storage: primary and secondary. Primary memory is where programs and data are stored upon execution. An example of primary memory is random access memory, or RAM. It is used to store programs that are in use by the parts of the processor because it operates faster than secondary memory. Secondary memory is where the programs are stored after primary memory is done using them. Examples of this are magnetic disks, or hard drives, optical disks, CDs or DVDs, and flash memory, or flash drives. When information is taken from an input device and stored into memory, it will eventually get used in some sort of computation. The arithmetic and logic unit, or ALU, is in charge of computation in the processor, such as addition or subtraction, or other logic operations. For example, if 2 numbers in memory need to be added together, they would be loaded into the processor, into the arithmetic and logic unit, and added and output from the arithmetic and logic unit elsewhere in the processor. After this information is processed, it might need to be displayed or communicated back to the user. This is what the output unit is for. The output portion of a processor, or examples of the output portion of a processor, are devices like printers or monitors. The processor is told what needs to be printed or displayed and sends the information in a correct format to the respective device. An example would be video data being sent to a monitor through VGA, or a file being stored on a flash drive, or to a printer over USB. This brings us to the control unit. This is the piece that coordinates all the other parts of the processor to work together. The control unit is analogous to the nerve center of an organism, sending out control signals to the other parts of the processor to tell them what to do. For example, a key is pressed in the input and is meant to be stored into memory. The control unit needs to recognize that input has been initiated and tell memory that it needs to store it. Once it has been stored, it might need to be the computation might need to be done on this input. The control unit needs to tell the memory unit that this information needs to be loaded into the arithmetic and logic unit, while simultaneously telling the arithmetic and logic unit what to do with it. Once it is outputted from the ALU, the control unit tells the ALU where to put this information, whether it be the output or back into memory. All these functions are directed by the control unit. Just take a key press from a keyboard and put it on the screen, and this can get fairly involved in a processor. Everything needs to be coordinated by the control unit at precise times so information is not lost by the other parts of the processor. Today, we learned how a processor works by explaining what the 5 parts of a processor are and discussing how these parts interact to make the functionality and operation of a processor. Processors can be very complex, but since we use them in our day-to-day lives, it is important to understand the basic concepts and how they work.